I now want to look at the signs of a trig function. What quadrant the terminal side of the angle lies in can tell us about the sign of the trig function. The first quadrant, everything is positive. All of my trig functions are positive in the first quadrant. The second one, sine and cosecant are positive and everything else is negative. My third one, tangent and cotangent are positive. The rest are negative. And the fourth quadrant, cosine and secant are positive and everything else is negative. One way to remember this is A, S, T, C. You can think of it as a smart trig class as an easy way to remember it. A stands for all. It tells us that everything in the first quadrant is positive. S stands for sine. T stands for tangent. And C stands for cosine. So let's look at how to use this. Let's suppose we have an angle. We know that tangent of this angle is negative 3/4. And we know that cosine of theta is less than 0. So if I draw a very quick picture of this, the fact that tangent is negative tells me I have to be in either the second or fourth quadrant, since everything is positive in the first, and tangent is positive in the third. The fact that cosine is less than 0 tells me I'm actually in my second quadrant. The fourth one no longer works because in that one, cosine is positive. We know that tangent of theta is equal to opposite over adjacent, or y/x. Since I'm in the second quadrant, I know that x needs to be negative and y needs to be positive. So that tells me that in this case, y is equal to 3 and x is equal to -4. In that case, r is going to be equal to the square root of 3 squared plus -4 squared, which if you simplify, you get 5. So we can say sine of theta is y/r, or 3/5. Cosine of theta is x/r, or -4/5. Let's do one where tangent of theta is equal to 2/3 and cosine of theta is less than 0. So if I quickly draw a coordinate plane, tangent is positive in the first quadrant and the third quadrant. We want cosine to be negative. Everything is positive in the first quadrant, so I don't want that one. But cosine is negative in my third quadrant. In this case, both x and y are negative. So tangent of theta is equal to y/x. This tells me that y has to be equal to -2 and x equal to -3, since we need both of them to be negative. In this case, r is equal to the square root of -3 squared plus -2 squared, or the square root of 13. So if I want to find sine of theta, I can use y/r, or -2 over the square root of 13. Rationalizing gives me that sine of theta is -2 square root of 13 over 13. Cosine of theta is equal to x/r, or -3 over the square root of 13. Once again, we rationalize the denominator to get negative 3 squared of 13 over 13.